Hi, if you remember in the previous tutorial we looked at the reaction of ethanol with acetic acid to form ethyl acetate. During that reaction and the tutorial we worked out that 100% yield would give us, so that's 100% yield there, would give us 16.8 mils of ethyl acetate if we took 10 mils of ethanol and reacted it with 10 mils of acetic acid. We use this kind of formula or this kind of system to work out how many moles and how many molecules we're reacting together to give us our final product. So basically we took our 10 mils that we started with, we converted it to mass. From the mass we could then work out the number of moles of ethanol and number of moles of acetic acid that would react, and we use these equations to work that out. From that we work backwards effectively. We worked out that we should have 0. So this equated to 0.171 moles. This equated to 0.175 moles. So that's moles. And we worked out this had to be 0.171 moles because once that's run out you can't make any more, so that is 0.171 moles as well. Okay, we didn't work out the water, but the water should be 0.171 moles. Simply because once all that's run out, no more water will be formed either. So that was for a 100% yield reaction. Okay, so that was for 100% yield. If we did this in the lab, we'd be very lucky to get 100% yield because of all different things that happen. Also, it's not just based on the reaction of one molecule with another, it's how we could actually recover this material. You know, because when we pour it from one flask to another, we lose bits of material through, if it's a liquid, through what's called wetting. So it's just like having a drink of cordial or something like that, and as you finish your drink and you pour the rest down the sink, there's always a little bit of liquid left in your cup. It's the same with reactions. Obviously these are dangerous chemicals, so these are contained in reaction flasks, but the same thing applies when you transfer something, even the product. When you transfer it into a beaker, say from a round bottom flask, so there's your round bottom flask, not the best round bottom flask I've ever drawn, but, and there's your liquid in there, say, and that pours in and it fills your flask up. Okay, when we've finished pouring our liquid or ethyl acetate into the flask to weigh it on a balance, so say that's a balance. Okay, and that gives us the numbers, grams, yeah. Once we've poured it in there and weighed how much we got, this flask itself will have a little bit of the liquid left in, and that actually contributes to the yield as well. So we can lose material by the way we handle it as well. So not only will we lose some through the wetting, but also through the reaction yield and things like that. Okay. So why have I brought that up? Well, because we need to work out what our yield is. We've got 100% yield, we know what we should get, but that isn't always the case. So if I just get rid of this for a second, imagine we got 10 mils. What would our percentage yield be? So that's what we're trying to work out. We're trying to work out our percentage yield. Okay, what is it? So if we take 10 mils, what's the first thing we do? How can we tell our professor or our chemistry tutor or whoever we're doing this for, or even putting a number in our lab book, how can we work out what the percentage yield is? Could we just divide 10 by 16.8 and multiply that by 100 to find out? Possibly we could do that. But we don't always have liquids, we don't always, sometimes we have solids and things like that. But what we should do, we should work out how many moles are in 10 mils, just like we did before. And then we can compare how many moles are in 10 mils with how many moles are in this. So that's the approach we're going to use. We're not going to just look at volumes, because volumes can be affected by temperature, salts, impurities that are present as well. So we should always work out based on mass and other things like that. So we will work with moles. So we'll just get rid of that. We're going to look at 10 mils of ethyl acetate. So let's draw a line down there. So we're looking at 10 mils. Okay. So 10 mils, first thing we do is convert the volume to the mass. So given the density that we had before for ethyl acetate, the density, if you remember, and the molar mass was 0.897 and the molar mass was 88.12. We're going to use that in these equations. So the first thing to do is change my pen colour, is work out the mass in 10 mils. So the mass equals V times D, so mass is the one we want, and that equals V is 10 centimeters cubed, so 10 mils times the density, and the density is 0.897, 0.897 grams per mil. We'll have a look at the units. So we've got mils on top, mils on the bottom, so they should cancel themselves out, so let's put a line through them, and we're left with grams, and that's good because that's what we want for the mass. So the mass in that, pretty straightforward calculation because we've got 10 mils, should be, so M equals 10 times 0.897, which is 8.97 grams. Okay, so that's the first stage done. We converted volume to mass. The next stage is to convert the mass to how many moles. So 0.897 now needs to go into this equation, that's the mass bit there. We know the relative molecular mass, the molar mass here, so the moles equals the mass 8.97 divided by relative molecular mass, which is 88.12. 88.12. Let's get our units in there. Grams, and this one here is grams per mole. Okay, I've written it like that because you remember before this is going to be a reciprocal, and if you're dividing by that, that should go up to the top, and the value for that will just bring the calculator back up. So the value for that, if we put it in the calculator, is 8.97 divided by 88.12 equals 0.10179. We only went to 2 decimal places here, we'll do the same again, so it's 0.10, okay, because that's a 1 there, so we'll leave that as 10. Move that over there. So that equals 0.10 moles. Okay, so 0.10 moles instead of 0.171 moles. So what we need to do now is work out our percentage yield. So just move these over a little bit because I've run out of room again. I always seem to run out of room. Let's just shrink that down. Keep that there. So now we need to work out our percentage yield. Let's move that up as well. Now the percentage yield should be, get my brush, 0.10 moles divided by our theoretical amount, 0.171 moles, times 100 to give it a percentage. Now bring the calculator up again. We divide this value now by 0.171, we get 0.59, and we'll stop there. Well, we'll carry the 5 over actually, so that would become 0.60. Okay, 0.60. 0.60 times 100, so times 100, gives us a percentage yield of 59.53%. Okay, we have to be very careful with the amount of decimal places we're using here, so I'm going to quote for this one 59.5%. okay, 59.5%, and that is our percentage yield. 59.5%. So that's how you work out percentage yields. First of all, the process of doing it was know what your theoretical yield should be. Know what the theoretical amount of moles should be. That is 100% yield. You then work out what you did get and work out how many moles of that substance you actually had, and from that you divide the amount you have by the theoretical. So it's, let me just write that in red. So you write the amount obtained divided by, that's a B, the amount obtained divided by the theoretical yield, okay, theoretical amount you got, times 100, and that should give you your percentage yield. Okay, so apologise for the scruffiness of this. It's the pen's not behaving itself. So this amount obtained divided by the theoretical yield times 100 will give you your percentage yield, and that is how you calculate percentage yields.